That last video ended somewhere in the middle of me explaining this. I think I went over B, that this straight line was, this straight area is where the runner was at a constant speed, because the straightness of this line demonstrates that every time you go over 1 second, you go up 10 meters. So a change of 1 second here from 9 to 10 corresponds to a change in distance from 50 up to 60. So this is just a constant speed. It's constantly a speed of 10 meters per second for every second, going up 10 meters. Now that changes when you get to this area, and it changes right here. So in this area, for every second that goes by, you're at 0, you're at 0, you're at 0. There's no change. Now here's where it starts to change. When you see the curve, that's meaning that you weren't really going up very many meters per second, but now you're starting to go up more, which means you're speeding up. So from here to here, from the 3 second mark to the 4 second mark, that's over 1 second. Somebody's going from 0 meters to about right there, which is a little less than 5. So they went a little less than 5 meters per second. But from the 4 second mark to the 5 second mark, they're going from like 4 meters to a position of 10. So now they've gone 6 meters in that second. And then in the next one, they're going even faster. So really, this curve straightens out right at the end. So in the beginning of this, they're going a little slower. At the end, they're going a little faster. But just for this question, all you really need to know is that an upward curve where it gets steeper, wherever the slope gets steeper, that means there's acceleration. They're speeding up. And wherever the curve gets less steep, that's deceleration. They're slowing down. Moving on. Excuse my sniffling, please. All right, these are tricky for a lot of people. You have to associate this graph of position versus time with one of these two graphs, or one of these 4 graphs of velocity and one of these graphs of acceleration. I'm going to show you the easy way. I kind of talked about the hard way in the previous question, but this is the easy way now. So first, whenever you have a position versus time graph, it's straight like this, that shows constant acceleration, or sorry, constant velocity. So a straight line, you could say linear, means constant velocity. And constant velocity means 0 acceleration. Curving up, what that means is increasing velocity. And what an increasing velocity means is positive acceleration. If something is curving down, that means decreasing velocity. And decrease in velocity means negative acceleration. And I guess I need to add on, just for the straight ones, an upward slope is positive velocity, and a downward slope is negative velocity. Alright, so putting all these to use, first thing we do is look for straight or curved, and then we'll go from there. So this first one, this is a straight line, which means the velocity is constant. And since it's sloping up, the velocity is positive. And what that positive means is, if you look at the position starts at 4 after 0, After 2 seconds, the position is at 4. After 4 seconds, the position is at 8. So the position is growing in a positive way. It's getting bigger. If it were going from 0 to -4 to -8, that would be a negative velocity. So we've got a positive velocity, and it's a constant velocity. We need to find a velocity graph where the velocity always stays the same and it's a positive number. This won't work because the velocity is changing, it's decreasing. This one, the velocity is always the same, it's always 2, and 2 is a positive number, so that's it. That's the graph. I'll just stop there. Now this next one, this one's curving upward. It's getting steeper. Another thing I'll write is steeper equals faster. And I could discuss with you why that is, but I'm not going to. Right here. It's good to know though. So this is getting steeper, which means it's getting faster. This one's accelerating. It's curving up, so it's increasing velocity, it's positive acceleration. And since this is actually going up, it's an upward slope, we've got a positive velocity too. So one more time. Curve means there's acceleration. A curve up means positive acceleration. And the fact that it's moving up means the velocity is positive. So accelerating means the velocity is getting faster and faster and faster. There the velocity is going down. Here the velocity is staying the same. Here it's staying the same. Here it's going up. So that's the one. That's the velocity graph right there. You know what? I didn't do acceleration on the last one. So we decided that this, since it's straight and it's going up, this is represented by that velocity graph where the velocity is always the same, it's positive. If the velocity is always the same, then there's no acceleration, 0 acceleration. And B is the only one with 0, where the acceleration is 0 the whole time. Now on this one, we decided that was an increasing velocity, so the acceleration is positive, and the velocity is increasing, and that was this graph. So we look for an acceleration graph that shows a positive acceleration. And if we want to see exactly what that is, we can figure out a number. Here the velocity is 0 at time 0, and at 5 seconds the velocity is 10. So the change in velocity is 10 divided by the change in time, 5. That'll give us 2 meters per second squared for the acceleration. We just need to find one of these with an acceleration of 2, and there it is. So even if you didn't do the numbers, you could, excuse me, still got a cold, you could figure out that this is, the velocity is going up, so you have positive acceleration. Acceleration where velocity is increasing. There we go. Now to this graph. It's going up. It's going kind of like uphill, so that means we've got a positive velocity, but it's curving downward. This is an upward curve, this is a downward curve. So we're looking for a velocity that is decreasing. This is slowing down. The only one where velocity is decreasing is this one, and the velocity is positive the whole time. It's just losing it. It's going from 10 down to 5 down to 0. So that's the graph right there. This is not decreasing, staying the same. This is staying the same. This is going up. So the fact that this doesn't go straight, it curves that way. That's a downward curve. If it had done this, that would have been an upward curve, and we would have been looking for velocity to do that kind of thing. But here's what our velocity is doing because it's curving down. Velocity is going down. Now, if velocity is going down, that means we have a change in motion, which means there is acceleration, except it's negative. The velocity going down means it's losing velocity every second. We could just go ahead and jump ahead. This is the only one with negative velocity, or sorry, negative acceleration. It's -1. This has 0 acceleration. This has +2 acceleration. So that's got to be the one. This last one, the slope is going down, and it's a straight line. It's a straight line, so that means this is a constant velocity. It's going downhill, which means our velocity is negative. If somebody's standing at 12 meters, a little while later, they're going to be standing at 8. A little while later, they're going to be standing at 4. So they're moving backward. So we're going to have a negative acceleration, but it's going to be the same all the time because this line is straight. And that's this one. This is the only one where it's -1, it's a negative number, and it always stays the same. Now, if the velocity doesn't change, what's the acceleration? If there's no change in motion, there's no acceleration. So we've got to go with B again. Number 12, this is a good way to describe constant velocity. Something goes 8 meters in the first second, 8 meters in the second second, 8 meters in the third second. If it's always going 8 meters per second, that means it's got a constant velocity. And if you have a constant velocity, you don't have any acceleration. Your acceleration is 0. This one, 13, was a tricky one. It tricked me the first time. I kind of thought I knew what the answer was supposed to be, and then I thought about it and realized that I was wrong. I was thinking the answer was A, but it's really D. So it says, when an object is in free fall, which of the following apply? Here's an object. It's falling down. And I'm just going to come up with a little scenario here. If the velocity is 20 meters per second, well, let's make it -20 since it's already going down. No, let's make it 0. 0 meters per second. After 1 second, it's going to be going -10 meters per second because it's going downward. And after 2 seconds, it's going to be going -20 meters per second. So the acceleration here is -10 meters per second squared, which means for every second that goes by, you take off another 10 from velocity. It starts at 0, take off 10, you get -10. Take off another 10, you get -20. After another second, it's going to be -30. So now let's go back to the question. Which of the following applies? Velocity increases? Well, no. Velocity is going from 0 to -10 to -20 to -30. It's decreasing. Speed is increasing. It's getting faster. It's going 10 meters per second. It's going 20 meters per second. But the velocity, which has direction, that would be decreasing. So, but that's kind of picky. So I gave credit for circling that. That's okay. B, acceleration increases? No. Now the velocity and the speed are changing, but the acceleration is staying the same. It's taking away 10 during this second, taking away 10 during that second, taking away 10 during that second. The acceleration does not change. So really, if you're picky, this is the answer. It's not true that acceleration increases because it's always -10. And it's not true that velocity increases because it's getting more negative, which is not an increase. But I'd take either one. Number 14, if something were equipped with a speedometer, its speed reading would increase each second by 10 meters per second. What that's saying is, if you had a speedometer on this baseball, or you were just riding the baseball, like you're riding in a car or something, your speedometer wouldn't say -10, it would just say 10. And it would say 20 here. And you would feel yourself get faster and faster. So speedometers, like this odometer on the previous page, or one of these pages, speedometers don't tell you direction. It just says 90 miles per hour, 100 miles per hour. It doesn't tell you whether you're going north or south or east or west. So if you were going downward and you had a speedometer, it would just say 10 meters per second, 20 meters per second, 30, it would increase by that much every second. People who picked this probably were thinking that the object was not freely falling. Free fall means there's no air acting on it. If there is air, then after you've been falling for a while, you don't speed up as fast because you get close to the terminal velocity. Now for problems. Number 1, rocks falling from a cliff. So remember I said every time you hear about something falling from a cliff or in the air, write down A equals -10 meters per second squared because you're going to need it. So how high is the cliff? That's a distance. You're looking for distance. If you see how high or how long or how far, that's always distance. What formula would you use? Well, you know this because you wrote that down, hopefully. You know a time, so you're looking for a formula for distance that has acceleration and time in it. And distance with acceleration and time, it's that formula. Your formula sheet looked a little bit different, but that's it. Substitute in your acceleration, 1/2 times -10 times 10 squared. You really got to make sure that you square this, so this becomes 100 seconds squared times -10, which gives you -500, or sorry, -1000 times 1/2. And that actually gives you -500. But it should be 500 because the question is, how high is the cliff? So it's plus 500 meters. I didn't take off points if you didn't have the positive there. Make sure you have the units. Correct units is meters. Number 2, this is asking about a runner. What was their average speed? Average speed. Now, speed and velocity are different, but if you're given a choice between, are we asking for distance, velocity, acceleration, or time? Speed is velocity. So look up the formula for average velocity. I don't know why the question was phrased that way. Velocity, average velocity is, where is it? There it is, d/t. Plug in the distance, plug in the time, divide them, and just write the units like you did before. 100 meters over 10.49 seconds becomes 9.53 meters over seconds. You could say 9.5, that's all right. How long does it take Barbara to walk a distance? So how long? We're looking for time. And if you scan through this, we're given a speed or a velocity, and we're given a distance. So you're looking for a formula with time, for time, that has distance and velocity in it. That's the one. Make sure you put the distance on top, the velocity on the bottom, divide, you can get 250 seconds. Now, the units in this question, I guess, could be kind of tricky, but it's going to be a unit of time. And you just look at, okay, we've got feet there, we've got feet there. The only unit of time in the whole question is that, so your answer is going to be in seconds. Number 4. This one was a bad question. The world's fastest sprinter is accelerated at a rate of 3 meters per second squared. So this is showing a runner, and the runners, I'll just have them standing here. And then after a little while, the runner's running really fast because the runner has accelerated. And what the question says is they start from a standstill, so they're going 0 meters per second. And a little while later, how long does it take them to reach a speed of 12 meters per second? A little while later, they're going 12 meters per second. And you know the acceleration is 3 meters per second squared because it says that in the question. So what you've got to figure out is how long? What's the amount of time? There's another question in here too, but that's the first thing to do. So you just fill in what you're given here. The final velocity. Final velocity is this. That's how fast they're going in the end. That was so obvious and easy, it was confusing. The acceleration of this person, that was given also. It's right there. So you just write those two things down. The time, now you go looking for a formula. You have velocity, you have acceleration, and the formula that gives you time is t equals v over a. That's the only formula for time on this sheet that you can calculate with v and a. So you plug in your final velocity and plug in your acceleration, divide them, and you get 4 seconds. So that's how long it takes for somebody to get to here. So this is a time of 0 seconds, this is a time of 4 seconds. Now we've got this other question down here. It's not stated here, but it's stated here. How far do they go in the first 3 seconds? So this took 4 seconds to get to there. If they were just going for 3 seconds, how far would they go? So what we have to help us figure this out, we want how far, so we want distance. And we're looking for a formula for distance based on what we know. We know this is the acceleration, and we know the time, 3 seconds. Now some people used 4 seconds because they came up with that earlier, but the question is how far do they go in 3 seconds? So I'm just going to write acceleration is 3 meters per second squared. Time equals 3 seconds. So I'm going to go looking for a formula that has those things in it, and it gives me d, and it's d equals 1/2 at squared. So that's what I was doing here. D equals 1/2 at squared. I plugged in my 1/2. I didn't plug it in, it's already there. Times the acceleration, which was given, times the 3 seconds, and I get 13.5 meters. These are other answers that people might have gotten by interpreting this question different ways. Last problem, rescue plane's dropping this package and it's falling 320 meters. How fast is it going to be going when it hits the ground? You've got to fill all this out, and it says make sure you have correct sign on all your answers. I'll draw a little picture. Here's the package falling from the sky. I'll make it look like a box. It's falling down out of the sky, and it's fallen a distance of, this is like 0 meters, this is a position of 320 meters, and first thing I'm asked for is acceleration. It's not given anywhere, but it's falling from the sky, so we know the acceleration is -10 meters per second squared. And we know this distance. Now, I wrote the distance down as -320, and it really should be, because the distance it's traveling is a downward distance, so it should be negative. If it were going upward, we'd use a positive one. To calculate this amount of time, we've got to find a formula for time that has those two things in it. It's got acceleration is -10 meters per second squared, and distance -320 meters. Oops, sorry, I don't know why I wrote it like that. So find a formula for time with both of those. I've lost my formulas, but at any rate, it turns out to be this formula. T equals square root of d over a. You plug in the distance, which is -320. Plug in the acceleration, -10. When you multiply these two together, you get -640. And then when you divide that by -10, you get 64. Now, if you didn't put the negative in here, then you'd have 640 divided by -10, which would be -64. And you can't take the square root of a negative number. If you get to that place, that should remind you that you probably used something, you messed up somewhere. And it's probably something that should have been negative that wasn't. So if you didn't make this negative and you got to that point, hopefully that's a reminder that, oh, in order to make sure I've got the correct sign, I need to go back and make that a -320. So the time is 8 seconds. And there's one more question. What's the final velocity? It's a pretty easy one to do without a formula once you're familiar with all this stuff. If you're falling for 1 second, you're going to be going -10 meters per second. If you're falling for 2, you're going to be going -20. If you're falling for 4, you're going to be going -40. So 8 seconds means you're going -80. There's also a little formula for it. Final velocity is acceleration times time. There's the acceleration, there's the time, and you get, why did I write 0 here? Oh, the 0 goes with this answer, with this graph. So -10 times 8 is -80. The bonus, in case you're wondering about this, actually, I'm not going to go over the bonus. Went over those in class, and this is just for people who really need to focus on the other problems. I don't want to make this too long. That's it.